So we're going to do systems of equations and linear inequalities. So you have two or more. We're going to have some later that have more than two. Linear inequalities. Graph together. Okay. The solution is the overlapping region. So it has to work in both. So you might want to get like colored pencils or crayons or highlighters or something because it kind of helps you see. I'm going to use colors here so you can see. So let's take a look at number one. Number one, I'm going to graph this first line in green, and I'm going to shade in green. Okay, and I'm probably just going to shade by like lines. Okay, so you go through at a -1, and my slope is a -1. So it's up one, back one, up one, back one. I would make these lines really long when you're doing these because you just don't know what the other line's going to do. And so that way you kind of have an idea. It's greater than, so I'm just going to take and put these lines like this in green because that's where the answers work for just that line. But a system is where it works for both lines. So I'm also going to graph this line in purple. So it goes through at a -5, 1, 2, 3, 4, 5. And I'm going up one, over one, up one, over one, up one, over one, up one, over one. Now, since I graphed the first line really long, I forgot to make that a dotted line, sorry. Okay, since I made the first line really long, I really don't need to worry about the second line back below because I know the answer is going to be somewhere up in the green. So I'm not going to count down and back. Now, this is less than, so that would be below. Okay, so where your final answer is in the area where they're both at. So I'm going to heavily shade this area so that I can tell this is my final answer. Okay, now some teachers make students write like S inside of it to say that's my solution. But that's kind of up to you. I mean, we're just kind of working on this. Okay, so let's take a look at the next one. So I'm going to graph that 1/3 x plus 7. 1, 2, 3, 4, 5, 6, 7. Up 1 over 3, down 1 back 3, down 1 back 3. And it is a dotted line, and it's shaded below. Okay. On the other one, I am going to graph it at 4, 1, 2, 3, 4, and I'm going up one, back one, up one, back one. Oh, it doesn't hit at nice places. Okay, up one, back one, and it's a solid line. That is greater than, so on that one I'm shaded above. So that means that the solution is in this area because it's where both of them are at. So I'm just going to kind of put an S here so we know that's the solution. All right, so I would like you, no, we're going to do number 3, and then I'll let you do like 2 of these. I don't think we need to do a ton. Okay, I think you know how to graph, but I think it could get a little confusing when we have more lines. So on number 3, if I do this first one, I have to solve it first. I have to minus the x, that's a -4y is less than or equal to a -x plus 24. Divide everything by a -4. And I get y is greater than 1/4 x minus 6, because I have to flip it. Greater than or equal to. Lost that sign. So I'm going 1, 2, 3, 4, 5, 6. And I'm going up 1 over 4. Up 1 over 4. Down 1, back 1, 2, 3, 4. Down 1, back 4. It is a solid line, and it is greater than. So I am above on this line. Okay, that is my area where I am graphing. All right, so now on the other line, it is solved. So I'm just going to go to 1, and I'm going to go up 2 over 1, up 2 over 1, down 2, back 1. I'm going to try to hit this line. In the real world, you're going to need that line, and it is also solid. it says less than, so that's going to go below where the y's are getting smaller. So now you can see, since I used those colors, you can see where both the red or the green and the purple are is in this section right here. Okay, so this is going to be where my solution is at. Okay. All right, so I am going to have you just do a couple of these on the back side here. I'm not going to make you do all of them. I'm going to have you do number 7. I'm going to have you do number 9. That one's on purpose. Number 9's kind of weird. So if you get kind of stuck on that one, that's fine. And number 8 and number 10. I'm going to have you pause the video, and I want you to work all 4 of those. And then we're going to look at the story problem. Okay, so on the first one, it is solved. So I'm going to go 1, 2, 3, 4, 5, 6, and I'm going down 1, 2, 3, 4, 5, back 1, 1, 2, 3, 4, 5, back 1, and it is a dotted line going this way, and it is less than, so it's where those y's are getting smaller. Then I'm going to do the other line is at a -1, and I'm going up to over 1, up to over 1, and it is a solid line, and I am going above, so I'm going this way. So my final answer is going to be where both of them are at, which is in this region out here. So my solution is out there on that one. Okay, on the next one, I would have to solve this, and that's not too bad to solve, actually, because I just have to divide it by 8. So that's a -5/4 x plus 3. So I'm going through at 3, and I'm going up 1, 2, 3, 4, 5, back 1, 2, 3, 4. Or I could go down 1, 2, 3, 4, 5, back 1, 2, 3, 4. It is a dotted line, and it is going greater than. Okay, if I do the other one, it is just a horizontal line at 2. It's solid. Right? And that one's going less than. So my shaded region is this area down here. And I'm going to just put the S there to show it's the solution. All right, so now to the tricky one. You're going to have to solve both of them. So I'm going to come over here and solve this one. I had -3x, and I get a -y is less than a -3x plus 6. Divide everything by a -1, which flips the sign, and you get 3x minus 6. Okay, so if I do that, 1, 2, 3, 4, 5, 6, I'm going up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1, and it is a dotted line, and it is going greater than. Okay, now I'm going to do the other line. So I'm going to -3x, and I get a -y is greater than a -3x minus 2. Divide everything by a -1. And y is greater than 3. No, I have to flip the sign and divide it by a negative. 3x plus 2. Now, look at these slopes. Those slopes are the same, which tells you they're parallel lines. So I'm going through at 2, and I'm going up 3 over 1, up 3 over 1, down 3, back 1, down 3, back 1. Dotted line, these things are never going to hit. This is going less than. So where are the purple and the green the same? They are the same in the middle. So my solution set goes right through the middle of this thing. Okay, and then the last one, I'm going to do this guy first. -5x, you get 2y is greater than or equal to a -5x plus 4. Divide everything by 2. Y is greater than a -5 halves x plus 2. So I go through at 2, up 1, 2, 3, 4, 5, back 2. Or I can go down 1, 2, 3, 4, 5, forward 2. And I'm making a solid line. And it is greater than, so I'm going this direction. Solve that guy, I'm going to -x. and I get 4y is less than a negative x minus 8. Divide everything by 4. Don't forget this has a 1 with it. So y is less than a negative 1/4 x minus 2. So I'm going up 1, back 1, 2, 3, 4, down 1, forward 1, 2, 3, 4. So again, these don't necessarily have the nicest intersection points, but that's okay. So I'm going less than, so it's down here. So that means that my shaded area is going to be down in this region. Okay, solutions down here. All right, so we're going to take a look at this last application question. Sarah's pet store never combined, Sarah's pet store never has more than a combined total of 16 cats and dogs. So I'm talking about cats and I'm talking about dogs. So never has more than 16. So x plus y can never be more than 16. Can it be 16? Yes, because it can never be more than 16, but it doesn't say it can't be 16. Then it says, so that's my first line. She's never had more than a combined total of 16 cats and dogs. Okay, I'm going to read this next one. She also has never had more than 9 cats. So she's got to have less than or equal to 9 cats. Okay, write a system of inequalities. Now, if you notice the graph over there, I'm just going to kind of talk about this really quick. The graph is like that because you have to have more than 0 cats, greater than or equal to 0 cats and greater than or equal to 0 dogs. You can't have negative cats and dogs. So we're only talking about the positive part of this graph because we can't have negative. We could have 0. Okay, so if I were to graph this, the red line is at 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So I have a line here and it's going less than. You cannot have more than that line. She's only ever had 9 cats, never more. So now I'm going to minus x, and I get y is less than or equal to a negative x plus 16. So I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. You're going to want to go until you hit the red line. So I hit that red line, right? And it's less than that. So that means that my solution is in this area. So someone might ask you, could you have, because this is cats and this is dogs. And someone might ask you, can you have 8 cats and 17 dogs? Well, if I go over 8, 1, 2, 3, 4, 5, 6, 7, 8, and up 17, right? That's not inside the shaded region. Yes, it's less than, I have less than 9 cats, but I don't add together. So we're going to talk about these in the next section, these word problems. But today on this assignment, you're just going to kind of start setting up the graph.